Good morning, class. How are you doing, all of you? So, yesterday we finished off with the playing with constructions chapter, and from today onwards, we will start with the new chapter, that is symmetry. Now, symmetry. What is symmetry? Symmetry is repetitive pattern. What kind of repetitive pattern? It can be anything like a flower. If you have a flower, and then what is symmetry? Each of the petal is grown along the center of the flower. So this has symmetrical, this is a symmetrical figure, you can say. Symmetrical figure, because you have repetition of petals from one to another. Okay, so flower is a symmetrical figure. Each of the petal is of same shape and almost looks symmetrical, or giving it a very unique kind of look. It looks so interesting to see this pattern. So repetitive patterns are also seen in other cases, like if you have a butterfly, then what is the symmetrical pattern in a butterfly? If you see a butterfly, again it looks very attractive. Why? Because it has some sort of symmetry. The wings of the butterfly are having a repetitive pattern along its body. So you can say that this is also a symmetrical figure. Again, a repetitive pattern. So whenever there is a repetitive pattern of some sort, you say that it is a symmetrical figure. Now suppose I draw a circle. So let's draw a circle. This is a circle. Now you can say that how we find the symmetry over here. Suppose I join two points opposite to each other like this. So you will get the symmetrical figure. One portion, if I shade one of the portion and fold it along the other side, then it would overlap each other. What do you see in symmetrical figures? When you overlap a part over the other, then they superimpose each other. Superimpose means they completely overlap each other and you get a symmetrical figure. So circle is also a symmetrical figure. We can see from making a circle on a piece of paper. So let's draw a circle over a piece of paper. Over a piece of paper and cut it along the boundary of the circle. So we are cutting Then putting the center, you can overlap one part over another. Again folding, you can overlap another part over the other. So like this, you can have a symmetrical pattern in the circle. So like you have a wheel. So how the wheel is made? It has number of rims. So all these rims are arranged in a bicycle wheel. All the rims are arranged in a symmetrical pattern. So in this way you can get number of examples in your surroundings where you look at where you see the symmetrical pattern. Similarly, when suppose this is a circle and I make a rangoli, all of you see a rangoli. So rangoli also has repetitive patterns, or it looks so beautiful when you look at rangolis. So all the rangolis you would get would have some sort of repetitive patterns in it, and you can have dots here. So in this way the symmetry is seen around us. Then suppose you have a book. Now this is a notebook. You have lot of pages in it. Now each of the when you open the notebook, it is like this. So when you fold it, so this is also a symmetrical figure, like it has some rectangle at one part and rectangle at the other portion. So when you overlap one rectangle over the other, they totally superimpose on each other. They totally overlap each other. So you can say that it is also a symmetrical figure. So like this you also draw certain patterns, and by cutting of paper in art and craft you get symmetrical patterns in them. Now suppose I have to make a hexagon. What is hexagon? First of all you should understand what is hexagon. So hexagon is a figure made up of 6 line segments. All of them are equal, and you can have the folding of the hexagon from one corner to another, so your hexagon would overlap each other. Now let us make a hexagon properly and then see how. This is a 6 segment figure. Suppose I join the opposite points, so we get a diagonal over here. Joining the opposite points we get a diagonal. So this is a repetitive pattern. See here, half of the portion is divided, the full hexagon is divided into half of the portion, and one portion can overlap the other. Similarly, if I draw another diagonal, then also there is some sort of repetition and it is looking like a symmetrical figure. If I make one more diagonal, then you can see that the hexagon gets divided into a symmetrical figure. What is this figure? One of the symmetrical figure is a triangle. So hexagon is made up of number of triangles, symmetrical triangles, and you get the hexagon. We also make it over a piece of paper so that you know how to draw. Suppose I take a ruler and draw a 4 centimeter line. Okay, so we will draw hexagon out of it. Now join these 2 points like this. Then draw another triangle. Whose center is same as the previous one. Then again open the compass equal to the segment and draw another arc from these 2 points like this. Are you able to follow what I am drawing? I have taken one side of 4 centimeter and making a hexagonal figure. See how I am making one of the center is common. I am drawing the arc. The other arc is taken from the corner side and cut the previous arc. So in this way you get a figure, a triangular figure out of it. So in this way you get the hexagonal figure. And when I complete the figure, this figure seems to be symmetrical about many of the folds. You can fold half of paper from here. Suppose I name the figure A, B, C, D, E, F. So we can fold half of the figure along E, B and E. Then it is symmetrical. We can fold the figure along AD. Fold the figure along AD and we get the symmetrical figure, total overlapping of one portion over the other. So this is how symmetrical figure looks, and they look very interesting and unique in some pattern. They have some repetitive pattern here. The triangle is the repetitive pattern. So this is how you can see that there are symmetrical figures. Now some of the pictures in your book is given where there is a temple and temple gopuram is shown. So this is also a symmetrical figure, seems to be symmetrical figure about the standing line in the middle. So in this way you get lots of examples of symmetrical figures. Now we will define line of symmetry. Line of symmetry. What is line of symmetry? the line along which you fold the figure is folded and it completely overlaps the other portion. You can say that one part along the line, along the fold, completely overlaps the other part. So that is called as line of symmetry. Okay, so understand the definition. The line along which, when the figure is folded, the one part along the fold completely overlaps the other part. That line is called as line of symmetry. Okay, so here also we are saying, now suppose I have this butterfly again. Now what is this repetitive pattern you are looking at? There are two wings on one side and two wings on the other. So if I draw a line here in the middle along the body of the butterfly, then when you fold one part over the other, then it is this first part, or you can say left part, completely overlaps the right part. So you get the line of symmetry as this, which is drawing at the center. Similarly here I have explained already that if you take EB as a line of symmetry, so you would fold the hexagon and you would get the completely overlap each other. So let me quickly make a hexagon out of piece of paper so that you understand that how the line of symmetry can be found. So let me make hexagon again, or I can just simply show this line of symmetry from the circle which we had done. This is a circle. Now I fold this circle along the diameter of the circle. What is diameter? The line joining two points passing through the center is the diameter. So suppose you make a diameter of a circle. Now this diameter, if I fold along this diameter, the circle, one part of the circle completely overlaps the other part. So this fold or this diameter is the line of symmetry. This diameter is line of symmetry. Similarly, you can make some other diameter in this circle. This I have made another diameter. If you fold along this, then the half of the part of the circle overlaps the other part. So this is also a line of symmetry. So whenever the figure is folded along the line of symmetry, one part completely overlaps the other part. Now we come to a triangular figure. So let us make a triangular figure. like we have here in hexagon. So what is the line of symmetry of a triangle if it is asked? So let us make a triangular figure first. Four centimeter line like this. So this is a triangular figure. Now what would be the line of symmetry? If I draw a line in between along this side, you would get the line of symmetry along one of the sides. From joining the vertex with the opposite point on the side, you get the line of symmetry. Similarly, if I take another corner here, suppose you have, since you have three corners in the triangle. So point B, if I take it and join the mid of the opposite side, joining the vertex with the opposite side, again you get a line of symmetry, because when you, suppose this is D point, when you overlap BCD over ABD, it will completely overlap. One figure would completely overlap the other. So let me quickly show you on a piece of paper how this works. So let us make a this is the piece of paper I have taken and drawing the so this is my triangle. Now cutting it, along the sides of the triangle. So this is a triangle. Now if I, as shown in the figure also, see it on page number, second page of this chapter, you would see that third page of this chapter, if I fold this triangle along the standing line, then I get the fold, then one part completely overlaps the other part. You can see from here, one part completely overlaps the other part. So what is the line of symmetry that I get? This fold is the line of symmetry for us. So this is the line of symmetry that we get in a triangle. Similarly, if I fold it some other corner, then also one part will overlap the other part. So I get another line of symmetry. So this we will study later, but right now you understand that what is line of symmetry. So now we come to figure it out. figure it out. Number 1. Question number 1. Question number 1 is, do you see any line of symmetry in the figures at the start of the chapter? So yes, we did see the line of symmetry for the flower, line of symmetry for flower, for butterfly, for triangle also you can say, or you can say for rangoli, and the paper cut figure which is made. So in all this, a type of repetitive pattern is there, and we say that we can see the line of symmetry. Then we see in the second page of the chapter, page number 218, we see that there is a repetitive pattern in Taj Mahal and repetitive pattern in Gopuram of a temple. So there seems to be a line of symmetry there also. So yes, we did see. What about the picture of the cloud? So cloud is not symmetrical figure, as there is no repetitive pattern. Okay. Then question number 2. For each of the following figures, identify the line or lines of symmetry if it exists. So as we did here in the triangle, that there are lines of symmetry. So you can have one or more line of symmetry for the same figure. So that you have to see that such that in this triangle I would also get the third line of symmetry by joining the third corner with the opposite side. So a figure can have more lines of symmetry. We would see the figure given in the book, question number 2. So first figure is, it is somewhat it is somewhat like this. So where do we find the symmetrical line of symmetry? If we join the mid of the figure, we get the line of symmetry. So this is how line of symmetry looks in this figure. This is line of symmetry. So you can make it with a dashed line to show the line of symmetry. Then second figure, we look at somewhat like a kite. this is the second figure. Now where would you look for line of symmetry? Suppose I fold, let us make this figure on a piece of paper also, so that you know that how you can get the line of symmetry in a given figure. So let me make it over a piece of paper. Let us cut the figure. So this is the figure. Now suppose you have 4 corners in the figure. Suppose I fold these 2 corners, the left and right side corners, and fold it along these 2. Then what is happening? One portion is not overlapping the other portion. That means the fold that I have taken is not a line of symmetry. Okay, see here, the upper portion is folded along the lower portion, so it is not symmetrical, it is not totally overlapping the second part. So this is not a line of symmetry. This fold is, the horizontal fold is not a line of symmetry. Do you understand? Horizontal is like this, and then you have vertical fold. You can have a vertical fold, you can have a slanting fold, so depending on the fold. Now see the other 2 corners. The other 2 corners, if I overlap, I fold it along the vertical line, then what is happening? This figure is completely overlapping the second part. You can see from here, it is completely overlapping the second part. So this means the fold that I have taken, which is a vertical fold, this is the line of symmetry. So you can say that the vertical fold is the line of symmetry. So in the figure, we will make the line of symmetry along the vertical. This is the line of symmetry. When you see the line of symmetry, what you should understand is that one part, that is, it is divided into 2 parts. So one part should be able to overlap the other part, then you get a line of symmetry. Now we move to third part. This is the third part. The figure is somewhat like this. Now, if we draw it on a piece of paper, and cut it along the segments, this is the figure I get. Now you can fold the figure in any ways. So suppose I fold the upper portion with the lower portion. Again, this is not overlapping completely, so I don't get any line of symmetry. If I fold this along the corners, see here, two corners I have taken. Again, the figure is not overlapping one over the other. It is very short. Then you can take the other corners also, like I am folding it along this line now. So when I fold it along these corners, again it is not folding. Then how other foldings can take place? You can take place the midpoints of the half of the lines. So if I fold it half of the line like this, half of the sides, these are the sides, 4 sides are there. If I fold it like this, again there is no overlapping. So you can say that this figure doesn't have any line of symmetry. There is no line of symmetry. Now we move to next one, which is an L-shaped figure. Now we draw this L-shaped figure over the piece of paper. You also draw on a piece of paper. Then you would understand better. So I have taken this figure as length of the side is 4 centimeter here, 4 centimeter here. Okay, and this thickness I have taken as 1 centimeter. So with this you get the figure, and now we cut it. So this is the figure you get. Now when you fold it along the corner of the L, then you would see that there is totally a overlapping of the two legs of the L. So what is the line of symmetry? Line of symmetry is the corner of the L. So this is the line of symmetry. Then the last figure is a triangle. So just by observing you can say that if you fold it along the triangle, join the corner of the triangle with the opposite side, you will get the line of symmetry. So in this way you can find the line of symmetry either by folding of the paper or just by observing the figures, that where it would get divided into half. This figure is divided into half, this figure is divided into half along the line of symmetry, and this triangle is also divided into half along the line of symmetry. So in this way you can get the line of symmetry. Now in the fourth part, one of the angles seems to be 90 degrees. So let's make it again. One is L and other is slanting line. So I think there is no line of symmetry for this figure. So fifth part, just rectify it, change it. It is no line of symmetry in this figure. So in this way we complete this exercise, and we will continue with further concepts tomorrow. So have a nice day. Take care, class.